In this example, we're asked to consider the statement, there exists a pig that can swim and catch fish. Express the negation of this statement using quantifiers so that no negation symbol is to the left of a quantifier, and then translate that statement into plain English. So what I think we should do first is start by defining some propositional functions. So first of all, the exists, let's just write down a couple things here. The exists, this is going to be our quantifier. So there's our existential quantifier. The pigs become the domain of discourse. Okay, so the pigs become the domain of discourse. So in other words, this domain of discourse is all pigs, right? So then the next thing, the pig can swim. Well, this is going to have to be represented by a propositional function. Let's call it p of x. And p of x is going to be defined to be, remember the symbol for defining is a colon and then an equals. And this is just going to say x can swim. All right, and then the last portion of this statement is catch a fish. So in other words, we need another propositional function. We'll call it q of x. You can use any letters you want here, but q of x is going to say x can catch a fish. All right, so just the way English works, the can is part of both of these, right? So it can catch a fish. All right, and so now what does the statement say? Well, it says there exists a pig that can do both of these, right? So now we need to include this conjunction here. So that's a conjunction, and we end up with this statement. So there exists an x such that p of x and q of x. All right, so there's the shorthand propositional function notation translation of this English language sentence. Now we want to negate the whole thing, right? So the negation of this, remember the negation symbol has to start outside. We want to negate the entire statement, right? So it's not true that there exists an x such that p of x and q of x. Now remember how the negation works. It has to hit both parts of this. So it's going to change the existential into a universal. So for all x, the negation then goes to the inside, right? So it's not true that p of x and q of x. And at this point, the negation has to hit this entire statement, and that's a De Morgan's law, right? It has to hit all the parts. That's a De Morgan's law. And so this then says, for all x, what's true on the inside? Not p of x or not q of x. All right, and so at this point, so there's our propositional function notation answer to the first part of this statement, or the first part of this question, example. The next part is to translate this one into plain English, right? So we can say this a couple different ways, but we want to translate it. I'll just kind of do it very similar to the way that it's written here. So this one we can just write as follows. For all pigs, either the pig cannot swim. So either, I'll just rewrite the pig again, right? The pig cannot swim, that's the negation. Or the pig cannot catch a fish. So now we can say it, right? Cannot catch a fish. And this is the English language negation. It's worded, it's probably not worded in a way that you would say it to a friend, for example. You would probably say, either all pigs cannot swim or catch a fish, right? So, or cannot catch a fish. There's ways to say, just make sure that in your English translation you don't lose the logical meaning there. But this one we just went word for word. This is perfectly fine for us. We're not trying to win any poetry awards or anything for this problem. We're just trying to make sure the logic is correct, and we're going to call that one complete at this point.